The next class of functions to think about that we're going to use the building block going forward are the trigonometric functions. And I know you're probably starting to panic, but yes, they're going to come back. We're going to need them again. We use them all the time throughout this semester. So there are a few ways to think about the trig functions. And the way you may have seen them first, or the way I'll talk about them first here, is in terms of triangles, or right triangle trig. What's the idea of that? Well, the idea of that is if I have a right triangle, the right angle is down there, and I call this angle theta. And with regards to that angle, we have an opposite side, an adjacent side, and the hypotenuse. And we can define all of our trig functions based on these sides here. Right, so the sine of the angle theta is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent, or sine over cosine. Then you have your three inverse functions, and by inverse I mean 1 over functions, not inverse. We'll deal with that later. You have cosecant of theta, which is hypotenuse over opposite, so 1 over sine. You have secant theta, which is hypotenuse over adjacent, 1 over cosine, and you have cotangent theta as adjacent over opposite, or 1 over tangent. And there are a lot of identities that we'll go over in due time, but here's your base setup for right triangle. However, this picture only really makes sense in terms of this right triangle here for theta between 0 and pi over 2, and not even equals, only strictly between these two values. Otherwise, you don't get a triangle to actually build from. Where do you go beyond triangles? Well, then you go into circle trigonometry. And then you have circle trig, which you've hopefully seen at some point before. If I draw the unit circle here on the plane, we will assume it's a circle, pretend it's a circle. This is the unit circle, and I pick a point on that circle. If I measure the angle theta to the positive x-axis, then the coordinates of this point are cosine theta for the x-coordinate and sine theta for the y-coordinate. Now in the first quadrant, these two things match, because if I drop down the perpendicular here, I will get exactly that hypotenuse is 1, because it's a unit circle, radius 1. The opposite side is thus just sine, because h is 1, sine theta here, cosine theta here. And so these definitions line up in the first quadrant. But thinking about it as a circle then allows me to go beyond the first quadrant. So I can then think about an angle that is, for instance, all the way over here, and take the angle from here all the way back to the positive x-axis, call that angle phi. And this still makes sense from the circle trig point of view. The coordinates here are just cosine phi, sine phi, and here both will be negative. And that's totally fine. From right triangle trig, you can only have positive values for sine and cosine. All right, and now the part that you despise trig, well, probably one part of it, the part that was the hardest to get through, and that's special angles. So yes, even in this class, you will still need to know your special angles for trig functions. And you'll also need to know how they relate to other quadrants beyond just the first quadrant. So for this case, work out a table here for just the first quadrant values, and then we'll need to extend that into other quadrants. So the normal special angles we have for theta are theta equals 0 over 6, pi over 4, pi over 3, pi over 2, and then pi, and it repeats from the circle between pi over 2 and pi, and then in all the other quadrants as well. Main ones to know for sure are sine and cosine. You can get away with just those two because tangent is sine over cosine, and the rest you can derive from those three. But we'll write tangent here as well. Big ones to know right off the bat: sine of 0 is 0, cosine of 0 is 1, so tangent of 0 is 0. Sine of pi over 2 is 1. That's now straight up, so your y-coordinate goes to 1 and your x goes to 0, so tangent is undefined. And at pi, sine is 0, cosine is minus 1, tangent's back to 0 again. Now, I'm going to fill in the rest of this table here, and then we'll discuss it after that. So here is that part of the special angles table for sine, cosine, and tangent. 1 over 2, or 2 over 2, or 3 over 2, and 1 is sort of the numbers you're always going to see for sine and cosine here. And then tangent comes with the ratio sine over cosine. Now, how does this connect to other quadrants? So say I want to know what the cosine of 4 pi over 3 is. Well, that's not on my list. That's bigger than pi and less than 2 pi. Let's figure out how that shows up here. Well, let's draw our circle and work backwards from there. So if I draw my circle, where is 4 pi over 3? Well, it is pi over 3 bigger than pi, which means it's less than 3 pi over 2. So it's somewhere around here where this angle is pi over 3. Because this angle here is pi, right? 0, pi over 2, and 3 pi over 2. It's that angle down there. But what can I say about the coordinates at that point? Well, whatever they are, we'll call them x and y for now. If I flip this angle up vertically instead, so instead of going down from the negative x-axis pi over 3, I go up instead, that this angle is pi over 3, I've just reflected over the x-axis. So I've made my y-coordinate negative, but kept the x the same. I can play this game one more time to get me back into the first quadrant, where now this angle is pi over 3. And I'm now at minus x minus y. But that I know. If the angle is pi over 3, I know that 1/2 is x, and root 3 over 2 is y. In this case, that's negative x and negative y, which means that my x value, which is what I want here, this will be the x-coordinate, this must be negative root 3 over 2. You can take any angle you want and shift it around the circle back into the first quadrant. And once it's there, your table gives you everything you need. So you don't have to memorize the entire 0 to 2 pi unit circle. You can, but it's better and easier, I think, to memorize the small one to the first quadrant and then know how to get back to the first quadrant wherever you have. You get that process and that algorithmic procedure down to how to get back to the first quadrant, because that's going to help you a lot more in solving these problems, and the way of thinking here will help you a lot more in solving a lot of other problems for this course. There's your basics of triangle trig, circle trig, and how to use it with special angles to figure out values of certain trigonometric functions.